Hello and welcome to section 10.8 and 10.9 of Mrs. Quinn's geometry class. Today we're going to talk about finding the volume of prisms that don't have a square or rectangular base. If you remember, the definition of a prism is a three-dimensional solid that has a polygonal base. And we've already done prisms that have a square base and a rectangular base. And today I'm going to look at other bases. For example, we need to be able to find the volume when our base is a pentagon that has 5 sides, a hexagon with 6 sides, or an octagon with 8 sides, or whatever the case may be. And so first of all, let's look at what a hexagon would look like. If this is our base of our prism, hopefully you'll agree with me, it's a regular hexagon. We can split it into 6 equal triangles. Now we are going to call the height of this triangle the apothem. And that word is only utilized when you're working with this type of a regular polygon and you split it into separate triangles. We call the height of that triangle the apothem. And I'll use those words back and forth just so you're familiar with that terminology. So we could find the area of this triangle, multiply it by 6, and we'll find the area of the base. That's what we're going to do today, and when we come back to class tomorrow, I will simplify that formula. Once you understand where it comes from, we can simplify it down into a base formula.
Parents, I need to ask you at this time to begin wrapping up any last-minute conversations you might be having. We are just about finished with our evening session of conferences. Staff will be heading out here in just a couple minutes.
Now it is...
We will be having conferences again tomorrow from 8 in the morning until noon. Palmer High staff, have a great evening. Parents, drive safe. We will see you in the morning.
It is really hard to draw a three-dimensional shape that you can see in 2 dimensions, but I'm going to try. I've got my hexagonal base on the top and my hexagonal base on the bottom, and we are just going to picture this triangle that happens here and here, and I'm going to draw this length is 5 and this apothem, or sorry, this length is 7 and this apothem is 5. Let's say my height is 20. And that's hard to visualize that unless you can view this part as the top, this part as the bottom. And first we're going to find the area of this triangle. Hopefully you'll agree with me that the area of the triangle is still 1/2 base times height, right? So I have 1/2 times my base times my height. And let's use centimeters for this shape. And I have how many of those? For a hexagon, I have 1, 2, 3, 4, 5, 6. So I'm going to multiply that by 6. That is simply going to be the area of my base. Now I'm going to have to multiply that by my height. And when I do that, I am going to get 3 times 35 times 20, which is 2,100 centimeters cubed. And we'll do more of these tomorrow, don't worry. All right, for the volume of a sphere, I'm going to plug in my radius, which is 4, and I cube it. When I cube 4, I get 64. Times 4 is 256. And I used inches, so I'm going to have my answer in inches cubed. And unless you're asked for an approximate volume, go ahead and leave it in terms of pi and give me an exact volume. To find the surface area, your formula is a little bit quicker. You're going to plug in 4. And I'm going to get 4 squared is 16, times 4 is 64, pi, and again I used inches, so my area is going to have inches squared. For tomorrow, I'd like you to try to find the volume of this sphere, the surface area of this sphere, and the volume of this cone on top of a cylinder. Here's your volume formula for a cone. Volume for a cylinder. You're going to add those together to find the volume of the whole shape. And I will see you tomorrow.